Hi everyone, today we are going to start Chapter 7 with Lesson 7.1, Exponential Growth and Decay. So the first thing I want to do is introduce you to the general form of the equation, and then we will talk about some more specific forms that we will use and when to use those. So the general form of the exponential equation is that y is equal to a times b raised to the x power. So this is a little different. Our x has never been part of an exponent. That's why it's called an exponential function. So now let's take a look at a couple of specific forms of this function that we're going to use. One is for exponential growth. So that means that something is growing very, very quickly. And so for that equation, we expand on this b value right here, and we say that b is equal to 1 plus r, where r is our rate. So the rate is equal to our percent increase. So we are increasing by a particular percent, and that rate is equal to that percent. However, in the equation, we don't write the percent. So if it was a 5% increase, we don't write 5. It needs to be converted to a decimal first. So make yourself a note that this is going to be written as a decimal. And we'll go over how to do that just to remind you here in a little bit when we do an example. We still have A, our initial amount, and y is our final amount. T now, instead of x, is being used as the exponent because that is going to stand for time now. So t makes more sense than an x. And then overall, this b value is called our growth factor. And in this case, since it's 1 plus r, and r is going to be a positive number, that means that our growth factor, b, is going to be greater than 1 overall. Now let's look at the opposite. Let's look at exponential decrease. So this is something, or exponential decay. This is something that is becoming a lower and lower value very, very quickly. So we have a very similar equation. The only difference here is that now we are subtracting our rate. So our rate is now equal to a percent decrease. And once again, this will be written as a decimal. T is for time, y final amount, and a initial amount. And now this b value, our 1 minus r, is a decay factor instead of a growth factor. And so the b value is still going to be greater than 0 because, if you write a percent, we typically would have something from 0 to 100%. So b will be greater than 0, or 0 is less than b, but it's also going to be less than 1. So these are the equations that we're going to use in a couple of examples.